Hi, this is Marina Lee, and I just finished my paper, so I decided to give you guys an overview of what I have written. So, my paper is based on the application of game theory in volleyball, and I was inspired to delve deep into this topic because I am a volleyball player myself, and I have played volleyball for over 8 years. And my primary position is actually an outside hitter, and I could also play the libero. So I just thought it would be fun if I could utilize some of the game theory knowledge into my daily volleyball practices or game. So I have basically constructed this investigation. So in game theory is widely applied in lots of fields including biology, business, computer science, and math. And so it could also be probably applied in sports science fields and sports statistical analysis because it will give coaches and players a better overview of the whole game situation in a scientific way and a less biased way. There are six sections in my investigation. The first would be the intro, and the second would be the lit review. The third would be and the fourth would be focusing on like the game rules and solving strategic equations. And section five would be like applying the situation to real life and data analysis. And the sixth section would just be a conclusion. So first of all, my paper is widely inspired by Lin's paper called "Applying Game Theory to Volleyball Strategy." I believe Lin is a professor from Taiwan who studies game theory. And in her paper, she modeled two situations. So she constructed a model between a middle blocker and an outside hitter and two blockers and blockers. And then in her second model, she constructed the situation between an outside hitter and two blockers. So in her research, basically, uh, these offensive player could choose for the first model could choose to spike in down in a straight line or cross court, while the blocker could choose to block in the straight line or uh, cross court. And in her second model, the offensive player could choose to um, spike a sideline spike or a sharp angle spike or an evade spike, while the defensive blocker could choose between a closed sideline spike, an open block, and a cross court block. So in her paper, she believed that the model constructed would be a zero sum game. So she thinks that no pure Nash equilibrium existed in the whole um, yeah in the whole situation. So she used the mixed strategy, Nash equilibrium, and partial derivatives to calculate like the results and also apply it into a more daily situation. And also, I am inspired by Walker's paper called Mini Max by at Wimbledon because it constructs a 2-on-2 situation in tennis. And yeah, and I like the way he constructed his paper. So a lot of my paper would be influenced by these two um yeah previous papers. So I have modeled a defense and offense situation between an outside hitter and a libero in a volleyball game. So in the game, the libero and the outside hitter would make decisions independently. The I would assume that the libero would stand in the middle of the back row because for most of the times the libero would be standing in the middle blocker's position, while while the hitter would hit from the left side of the opposite court. So this is actually a model I have created just to give you guys a better understanding of how the whole thing works. And so the player could choose to spike a sideline spike or a cross court spike, while the libero stands here and could choose to move left and to move right. So this is the table. This is my payoff matrix, and I believe that this would be a zero-sum game because in volleyball you either win a point or you lose a point. So the payoffs added together should equal to 0. And I have assumed that assumed that all the alphabets in this payoff matrix would be a positive integer, because if it's not, it would alter the calculations a lot. So I also assumed that the player would be right-handed, because for an outside hitter, if you're left-handed, the payoff for hitting cross-court into hitting sideline would be so much different than a right-handed player. And yeah, my matrix revealed that actually no pure Nash equilibrium existed, because you could see that minus a plus a would equal to 0. And this is a zero-sum game. And we could see that if the spiker chooses to perform, for example, a cross-court spike, the libero would need to move left in order to would need to move left instead of moving right, because a would be bigger than minus b, since all the all alphabets would be positive. And but if the player libero moves left, then the outside hitter should technically choose to conduct a sideline spike, because D is C is bigger than minus D. And so we could see that between the two players are interdependent, and their choices would always be opposing to each other, because they need to choose an opposing strategy in order to compete and to win. So this is my calculations, and I have using the really useful theorem right here, and I have calculated a few formulas in order to support further investigation, where I plug in all the numbers. So you can see that this is the probability of the player spiking of the libero for moving left, and this is going to be the probability of the libero moving right, and you can see here that it's the same. Yeah, so then I plugged in my actual numbers in my payoff matrix. And yeah, so we could see that when we plug this in, the probability for the player to move left, no, for 50% of the time, the player should choose to move left, and for another 50%, the player should choose to move right. While for the outside hitter, for 40% of the time, they should choose to perform a cross-court spike, while for 60% of the chance, they should choose to perform a sideline spike. And to maximize the player's payoffs, the strategy utilized should be similar to what I have shown above. And if this ratio is altered, the team would deviate from their strategic guideline, and the results would be inaccurate. And to place this into a life situations, coaches will need to understand how to change their strategy when a variable changes. So this is why I have constructed another partial derivative table showing that if, for example, if A increases, then M for player 2, which is a defensive libero, would decrease, while if B increases, then for the defensive player, the M would actually increase. So yeah, this shows how the coach should alter their strategy according to like the whole game situation, because sometimes a player could underperform while some player could perform better than expected, while the other team could be really strong in certain defense positions, and you will never know because this is a real life situation of a like constructed model. So yeah, in conclusion, this essay believes that there would be no pure Nash equilibrium um, present in the volleyball situation constructed, but then there would be this is where the mixed strategy Nash equilibrium would be used. And yeah, coaches could really benefit a lot if they had if this would be implanted in games. So yeah, thank you.